What's S represent?
It's just a coordinate, just a point.
Which ones are starting?
Okay, what does it look like?
A minus, makes a positive.
Negative 5 minus
5 minus 2 is 3.
That
And
shit, that's
3 minus 1.
That's not negative.
Doesn't that make it a positive? So it'd be 3 plus 1.
It went up 3 and right 4. Is that 3 over 4?
Okay,
No, it's a right 3, not 4.
Yeah, to the right 3.
so Will, you asked, how do you know which one's the end? Well, the end has the arrow on it, and the beginning is just the opening stick. So vector starting at R, ending at S, vector RS is the end minus the start, comma, end minus the start. So we get vector 3, 4. Yes? And if we check that, if I copy the vector over, is it going to end up being parallel?
Yeah.
It's going to be the same length? And does it look like we would have gone over 3, 4? Like that's where that ending coordinate is?
Mhm.
Yeah, okay.
Yes, sir.
I have a question.
Yes,
The thing that you wrote up right next to RS, can you read that out?
what about it?
Can you read that out?
5 minus 2, so the ending x value minus the beginning x value, comma, ending y value minus starting y value. 5 minus 2 is 3. 3 minus negative 1 is 4. So the actual RS vector is 3, 4 with the little carrots.
These are just the starting from that point.
Yep, starting point minus final point. Which is right there. Okay, so we said magnitude. Serene, were you in the room yet when we talked about what magnitude visually looks like on these lines? No? You definitely were, because I said, if this one's 3, how long is that other one? And you said maybe about 9. So William, it's the length of the line. How am I gonna find the length of this guy? Tycho, what do
Do
you
you want to do 4 squared plus 3 squared and then equals c squared?
think? Yes,
Oh,
okay.
wow, genius. You turned
Guys,
into a triangle.
once you have the vector in its standard form, which I highly recommend, that's the first thing you do.
The 3, 4, 5. Genius.
So magnitude, so William, you asked earlier about absolute value. Often we write a vector's magnitude of absolute value. It really means find its distance. And guys, can you look up for a quick second? Sometimes they use these double bars to be like, oh, it's not absolute value, it's magnitude. And Tycho is right to say, don't you just do Pythagorean theorem? Yes. With the component vector, so the magnitude of this one is 5. And the way you find it,
Direction is northeast, or do you want angles?
okay. Magnitude, how long is the stick? It is, if your vector is in standard form x, y, it's just the square root of x squared y plus y squared, don't do the square root. And William, you said you found the direction by doing what?
Just northeast, up.
But how did you get an exact number. I thought you said like 42 degrees or something.
I didn't.
Yeah.
Can we do the, what's this thing we do with the triangles? Can we do the?
Yeah, we
Well,
can.
Cosines?
One,
Or lost?
1/√2.
Okay, I don't need to do cosines or anything, but you guys are
45.
close.
45, yes.
This was 3, that's 4. How do I find that angle, Nick?
Easy.
How do I find that angle?
Tangent.
Tangent.
Tangent?
4/3.
I think you mean yeah, but not exactly what you said. What are we typing in on the calculator to get that?
Inverse.
Tan inverse. So guys, do that, tan inverse. So, sorry, someone asked, do we need our calculator? I was like, no, to get this, yeah, it's good. You got what, 53?
What would just be tan inverse of 4/3?
Yeah.
Okay, question though. What if my vector, I'm gonna call it vector CD. Doing the angle for that is tan inverse the y value over the x
Same
value.
thing.
We got 53 degrees also. Look at the picture of the vector. The vector, is that 53 degrees? No, it's, well, how do I have to change it to get,
And back to.
do what? Okay, so I'm asking, I changed the vector. Instead of moving right 3 and up 4, move left 3 and down 4. Tan inverse gave me 53 degrees also, which is clearly not right. How do I get the angle that takes me over here?
It's like the reference.
It's correct, the reference angle is 53, how do I find the angle at my,
I'm ready for the next one. Let's-
okay, so in this, you have to put the phone away. In this, you need to think about it on every single one of these. When you're finding direction, do I want the baby angle or do I want the bigger angle? Because tangent's only ever gonna give you this positive angle for quadrant 1, but sometimes you want it in quadrant 3.
So is that?
Well, you need to look at it. You okay over there? Dad's hands?
No,
So why do we need to find the angles of the quadrant?
Well, if this is my vector, and
Oh, thanks, okay.
I, like,
Oh, you need
I
to
don't
use a tangent.
in applications, there's a boat that's stranded, this is its vector, and if I tell you, oh, go help them out, go that way, you ain't gonna get there.
Yes.
does Pythagorean theorem work in real life?
Yes,
Okay. Why are vector opposites becoming negative? And why were they?
the vector's not negative,
I mean, like the
Yeah, why did you
CD
need
or whatever, why is it negative?
-4 over negative?
I just wanted to show you, okay,
Oh, you just wanted to do it, okay.
the original vector we worked with was RS, and then I made a different one and said it's exactly the same size, and tan inverse is gonna give us the same angle, but it's the wrong one, we need to fix it. So Monica was, okay, is that work?
How do we know that that's the wrong direction that we're going?
Okay.
Isn't the whole point of that to find the direction it's going?
Okay,
Lost.
let's try
No good.
another problem. Right. Roscoe's got my help. I want to get you guys through a few more things so that you can at least do the homework tonight. Do you guys know what the word scalar multiply means?
Yeah.
It just means multiply by a number.
Okay.
So Raneem, if, just take a guess, because I haven't taught it yet. If I tell you this is vector v, what do you think 2v would be?
-6, 28.
Okay,
Two times.
so 2 times that. What do you mean by 2 times that? What numbers would we get?
Multiply 2 by 3 and then 2 by 14.
Okay, so that's the question. She says, do we do the 2 times the -3 and 2 times the 14? Absolutely. So all this is saying is we went that vector twice. Same direction, same magnitude. So that's a scalar multiply, and the homework on Delta Math will be like, hey, what is 5v? Okay, 5 times -3, comma 5 times 14. Throwing the word scalar on there is not gonna scare you guys? Okay, okay. Monica, what about this one? If I tell you, this is vector v, same one as up there, and this is vector u, what do you think we would get if we added them? Okay, so what would we get?
Is U just another vector?
Yes, u is just another vector. So, real life things for this, it's like, okay, you were swimming in the water, the current was pushing you this way, those two forces acting at once, where do you end up? And what are you doing in engineering with the forces?
To be finished, but we're just doing like bridges, like that's basically what we're doing.
So gravity pulling this way and the trusses put, yeah, okay. And let's see. So there's vector 3, 14, and vector u. If I went from there, I went +6 down 8. If I added the two vectors together, I should end up at something that's about 3, 6. Looks reasonable. The next lesson, we're gonna work a lot more on adding vectors graphically as well as numerically. So Isabel, hopefully the first 2 questions are gonna help fix what you asked about a second ago. So can you guys do these problems? This is coordinate A, coordinate B, coordinate C. Find these vectors.
Second.
So we do this.
Sorry, what?
The cards. That's the first one.
Sarah, you want to have AB? Vector AB would be?
Oh, it's standing position. It's 4 minus 8.
Oh, when you're
So
open.
-4. 7 times positive. So
N times 4 minus -8, and 7 minus 5.
Oh, yeah, you were 12.
That's the ending coordinate. No. So, walking from A to B, B is the end coordinate, that is the y value of the end coordinate. Coordinate B, what is the x and y? Okay, the end coordinate for B is 7 minus the y value of A, 7 minus 5. Yeah.
2 AB. So what did we get for AB? 12, 2. So times those one, 2, so 24. 4.
With, 2AB plus BC.
Negative 2 more.
Okay, there's two steps of math, we have to answer.
So then you gotta add those. The 24 plus minus
So
6 is just
it
minus.
looks close.
4 minus 2. 22. 22.
You have to find standard position for all of these. So Sarah said for this one, Nick?
Oh. No, go ahead.
So standard position for this one, the ending value 4 minus the starting value.
Nice 8.
Yep. Comma, ending value minus starting value. So Sarah, what did you get as vector AB?
Times R for the first one. 12 and 2.
12 comma 2. Tay, how do we get vector BA?
Negative 12.
You do negative 8 minus 4. And then you do 5 minus 7. Make it negative 12.
Negative 12 and negative 2. So it's exactly the same magnitude, but opposite direction. And yes,
Can I
Nick?
do the next?
Sure.
That's just 2 minus 4 and 3 minus 7. So negative 2, negative 4. And the next one,
Okay,
you got to times AB by 2, so then you get 24 comma 4 plus negative 2, negative 4. I got 22, 0.
Monica, did you get that?
I got 10 and 0.
Sorry, you got what?
Minus 10 and 0. I don't know what I think I did.
Okay. Let's check. Did you do 2 times AB and get 24, 4?
I got my AB to be minus 4.
Because if you have AB or BC as different numbers, then you're not going to get their end answer. So 2 times AB is 24, 4. BC is negative 2, negative 4. And then
I see what I
Nick
did.
just added them. 24 minus 2 is 22. Positive 4 minus 4 is 0. Okay. Mia, how do I find the magnitude of AB?
Yes.
He's not. Sorry, Mia, how do we do this? Okay. If I drew this, and the way we draw vectors, we draw it from the origin going to the endpoint. The endpoint is 12, 2, and we put an arrow on it to say, if I started here, I was walking this direction. So Mia, how would you find the hypotenuse of that triangle? Pythagorean theorem. 12 squared plus 2 squared, which is the square root of 148. 12 and change. Okay, magnitude of BA is going to be the same thing because negative 12 squared became positive, negative 2 squared became positive, and that's 148.
Impossible.
So, Johan, how do I find the angle of vector A, B? How do I find this angle in the triangle that's labeled this way?
Can I use my phone to write? Because I don't wear my glasses.
We tan inverse over 12.
That's.
Eight over two.
Tycho says, I think you do tan inverse 2 over 12. What do you get when you do tan inverse 2 over 12? 9 degrees?
Yeah.
So Isabel, now here, this one, if I was to graph this vector back 12 down 2, I want that angle. The calculator is still going to tell me just 9 degrees. What is the actual angle that takes me all the way over there?
What are you doing?
189. Does that work? Okay, let's see.
What?
I don't wear my glasses today.
So what's your question?
That was 100%.
Yeah, yes.
But I figured, I just read that. I was wondering why we were figuring out that angle, then I read 5.
So it asks
Yeah.
here to find the direction and magnitude of AB and BA. Magnitude will be exactly the same. They are both the same length, but the directions are exactly the opposite. One is 9 degrees and one is 189 degrees. Yep. Okay. So there's 10 more minutes of class. Can you guys start the delta math so that I can get around and answer questions that you have?